Okay, hi again, everyone. We're on page 51 of our statistics class notes, and we're talking section 4.2, regression analysis, talking about the correlation coefficient right now. So we just got done doing an example where the R values were perfectly positive and negative correlations of 1 and -1. Now we want to look at what if we have R values close to 0. Well, those indicate a weak association, and then there's like a continuum. So between -1 and 0, that's all negative correlations, but the closer to -1, the stronger it is, the closer to 0, the weaker it is. Between 0 and +1, those are all positive correlations, right, uphill. And the closer to 0, the weaker it is, the closer to 1, the more strong it is. So let's visualize that. These are comparisons where we have all positive correlations. This one's pretty bad. I mean, eyeballing that, I would have thought maybe a line like that. I've actually let StatCrunch put in what's called the best fit line now, the line that actually fits through there to minimize the vertical variation. So that's actually the line that goes through them best. But the problem is it's so scattered. It's really, I mean, hardly any correlation at all. Very weak correlation of zero point 0.1. It is uphill though, according to what StatCrunch found. This one is also positive correlation. It's 0.33. I would say that's a pretty weak correlation. It's stronger than this one for sure, but it's fairly weak. And then when you get up closer to 1, like R equals 0.89, you can see the nice tight clustering around the line. Not nearly as much vertical variation. So what you want to notice is that as R increases, there is less vertical variation in the data. In other words, the trend is stronger. The correlation coefficient, though, we find using technology. So the table below shows the number of miles driven on a recent trip for 8 rented cars and the amount of gas in gallons used for each trip. Compute and interpret R. So we can use StatCrunch, and this is how you do it. I'll leave that there for you to read. Let me show you. Oh shoot, I forgot to start it, but let me go ahead and start it real quick. StatCrunch. You guys can watch while I do this. Why not? Get signed in here. You did not memorize my password, right? Oh, I typed it wrong anyways. Okay, I'm gonna get my data. I got to get my data for this. I already had it in here. Okay. Okay, so now I'm in StatCrunch, and this is, if I look back at our notes, so I had miles driven versus fuel consumption. So two numerical variables, and I want to be able to compare those using regression. So I'm going to go to StatCrunch again, and I'm going to look at these guys. Now, what did I do over here in my notes? Notice that I have the dependent variable. Remember from algebra, y is the dependent variable, x is the independent variable. I got to tell it which one to call x and which one to call y. So I matched what's printed out in your notes. I used y to be the fuel consumption. So going back, I'm going to go to stat. I'm going to go to regression, and I'm going to go to simple linear. That's all we're going to do in this class is simple linear. So I said let's let y be fuel consumption. That means x is miles driven. Okay, and don't worry about anything else right now. Let's just go ahead and compute that. And this is what I printed out. This very top here is what I printed out. We'll learn more about this stuff down there, but right now this is what I want you to see. Okay, so I cut and pasted this and put in your notes. Let's go back and look at your notes. So this is what we have, okay? So the only thing I'm asking you to understand through this example is where is R. So here's R, the correlation coefficient. Like I said, they use capital R for some reason in StatCrunch. The symbol for it is little r. So the R value, the correlation coefficient, is R equals 0.91 if I round that to 2 decimals. So that's pretty darn close to 1, and we would say then that there is a strong linear association between mileage and fuel consumption. Strong linear association between mileage and fuel consumption. I didn't show you the scatter plot yet, so I can't tell you whether it's positive or negative. We'll have to look at that.